So let's learn what you can do when you actually have the ability to construct a virtualization environment with security in mind, not as a bolt-on, but as something that you can consider from the ground up. Like when you lay the foundations, here's how you could go about it. Lee and Filippo, over to you.
Thank you. So we're going to start with a little bit of audience participation, an easy question to start. Who here has heard of the cloud? All right. We're in the right room, experts all around. Hello, my name is Lee Holmes. I am the lead security architect of Azure Management. So we have PowerShell, Automation, OMS, and Azure Stack, a very exciting thing.
And I'm Filippo Seracini, the program manager for anything related to security and compliance in Azure Stack.
All right, so Azure Stack is a cool thing. Anybody here because they're interested in Azure Stack specifically? Heard about it? It's exciting. So we're in this world of moving to the cloud. We've seen these clouds. There's been a couple big transitions on this big move, right? So the very first transition has been the move to people just trying to get rid of hardware, moving to infrastructure as a service, dumping their VMs into the cloud. That's really been the very first start to security. At that point, you don't have to worry so much about what's going on with your physical infrastructure. You can then say, I can trust Azure's data center to secure my operations and my hardware better than I can. So that's one good place to start. But of course, as we know, that's not the be-all and end-all when it comes to the security that you get by moving to the cloud. So the next thing you got to start to do, obviously, is now, if you take a look at the most services writing new services on Azure, it might not surprise you that most of Azure is written on Azure. Most of these people are using the platform as a service, where they're no longer managing their own VMs. They don't have to worry about the basics like patching and everything else. They went past the infrastructure as a service, so they don't have to worry about the physical. They moved to platform as a service, so they don't need to worry about the patching and all that kind of stuff. And then they're just being able to say things like, hey, yeah, I need a database here, a database there, some storage, a web server. And this is where you start to really get some amazing benefits for security, because you don't have to worry about your web server being patched if you don't even manage your own web server. When that's all being done for you at massive scale, massive automation, you get a huge benefit from security that way. And of course, the next step after the platform as a service comes from when you start to offer just services themselves, right? When I can start to offer email as a service or other things, then you're even the best. You don't even have to worry about the components of your service or your architecture if you don't even have any. But one of the big things that has made a big difference in the world of everybody moving to the cloud is this idea that now you know everything about it. You can offload all of these special skills that you used to have on defending your networks, defending your hardware, defending your infrastructure, defending your app service, all this kind of stuff. When you can offload this to a vendor like Azure, then you're in a great position because, hey, there are red teams that Microsoft is paying as much as they can to do as much damage as they can every single day, and then saying, thank you, may we have another, right? This is amazing and a great example of the kind of security benefit that people are getting today moving to the cloud.
And so basically, Lee just went through a lot of the benefit you get also from a security point of view when you go to the public cloud. But what if we could bring the public cloud to our customers in their data centers? Because believe it or not, there is still a lot of in the industry out there. There is a lot of our customer, actually the majority of our customer, they will not be able to move anytime soon, if ever, completely 100% to the cloud. Lots of them needs to be able to run their workloads on their data centers. And so basically, we wanted to, and the customer also asked us very clearly, hey, can we have that in our home, in our data centers? And here where Azure Stack came into place. So basically with Azure Stack, we went from these 40 data centers that Azure Stack, Azure has already. Now all of a sudden we have hundreds of data service providers out there. They're offering the same services that Azure offers in the Microsoft data centers. And then when you put also the enterprise inside, all of a sudden we scale to 1,000 places. So the services they offer run on Azure, the application that run on Azure, now can run in 1,000 other locations. Azure all of a sudden scale from 40 to thousands of locations worldwide, any places. And so that's really the power that came with Azure Stack. And just to give you a very quick overview what Azure Stack is, so we set sort of like the common concept. Azure Stack is Azure. It's just another region of Azure, but just it runs inside the customer data centers. So from a very high level point of view, the architecture of Azure Stack is the one of Azure. So on the top layer, you have the portal, the user portal, with all the command line, the programming languages, and the functionalities offered in Azure. The same one came down to Azure Stack. Below that, you have the Azure Resource Manager, the ARM, which is the API that exposes all the Azure functions, all the Azure services, so the IaaS and PaaS. The same ARM code came down to Azure. So Azure Stack. So Azure Stack is exactly Azure, the same code base. And underneath, you have the IaaS and PaaS capabilities. Obviously, Azure Stack, since we GA a few months back, is a subset of Azure, but it's a growing product, so it's continued to evolve and so on. And then underneath, you have the hardware, which here is where the two platforms diverge a little bit, because Azure is based on the OCP platform, the Open Compute Platform. Azure Stack, since it had to go inside the customer data center, is based on the commodity server from our OEM partners.
A great example of where we need to use Azure Stack needs to use cloud-inspired architecture and infrastructure. So when you start up in Azure itself, you want to stand up one stamp of storage. That is thousands of computers. Customers aren't going to be happy that says, we just need one little bit of table storage. Yeah, sure, I'm going to buy a couple thousand servers to do that. So that is where they really start to diverge. But the thing that Filippo was mentioning, absolutely, everything in your mind, think Azure Stack is Azure. And that drives a lot of decisions.
And so when now you have Azure that comes to your data center, you enable all these kind of like very cool scenarios. And here are a few ideas from customers that are actually looking at Azure Stack to implement. So we have people that want to put the Azure services on cruise lines. We have people, because all those locations where there is no connectivity, because there is no physical connectivity, like you are in the middle of the ocean, or you cannot be connected. Think of like all those military or highly sensitive deployments, data centers where they do not want to be connected to Azure, they do not want to be connected to the public internet. They want to be completely be air-gapped, but yet they still want to leverage the public cloud technologies. Here where Azure Stack can help them. The other one is to meet the regulations. So different countries have different regulation where data can be stored, when data can be accessed. Here with Azure Stack combination, now customer can choose whatever is works for them. And the third big use case scenario for Azure Stack is for those customers that have legacy applications. Believe it or not, there are people out there that are still running on mainframe with COBOL and Fortran. I have never even seen a line of code in Fortran. But yet there are people, major banks, that are still running on Fortran. So obviously when you think of moving from the Fortran on a mainframe to the public cloud PaaS technologies, the gap is so huge they cannot possibly handle it. So they see Azure Stack as an incremental move to sort of like start migrating out of the mainframe, out of the legacy into their on-prem data center, but using new technologies.
And this is a great opportunity for people to say, okay, we're ready to move you off of this crazy COBOL or Fortran application. What we're going to do is we're going to write the regular, a PaaS app or something like that, and that thing now you can feel like you've moved to this century, and then from there you can have your PaaS app or whatever now making local trusted connections back to your garbage, whatever you're trying to proxy. So a really great opportunity to start modernizing stuff.
And so in a very quick overview, these are some of the IaaS capabilities that are ready today in Azure Stack. And Azure Stack is a moving target because it's a live branch. So this is just today as a GA. As you can see, we already have a bunch of functionalities. More and more will come. And also we have the PaaS with Azure Function, Azure Fabric, and so on and so forth. And just to wrap up the introduction, so we are not here to sell Azure Stack. We also got a lot of incredible feedback from the customers, from the media, from the analysts, and Azure Stack has been defined as the secret weapon of Microsoft in the public cloud war, if you want. And so now, enough with the introduction, let's go to the fun part, to the security part of Azure Stack.
So one of the things we've been able to say with Azure Stack, and this is the theme of the talk today, is what have we been able to do with Azure Stack that we've been able to do by really understanding one thing. What we've done is we've taken a very bold step when it comes to hybrid cloud. People who talk about hybrid cloud today, they talk about, hey, first you deploy a bunch of systems and you harden them, and this is your domain admin, and this is the network connectivity and stuff. So you get a big checklist, right? So if you take a look at OpenStack, what it says to do to secure things, we had a private cloud platform that Microsoft did as well, cloud platform system and some other things, Windows Azure Pack. All those have had a very great document of exactly how to do these things. Azure Stack, by making a very, very strong statement that this is Azure, this is not just arbitrary compute and arbitrary machines, we've been able to make a lot of progress. So this is kind of how this stuff tends to start. Technical conference, let's talk about all the infrastructure. But no, you're not going to get that. Azure Stack's internals are internal. We could change this all to a new operating system or flip every edge from left to right, and it would not matter as long as we keep Azure Stack acting like Azure from the external perspective. So we've made this very, very strong statement to people that Azure Stack, this is not infrastructure. When people are taking a look, and they like to point to machines, and they're good at managing machines. And they start to ask things like, so what encryption have you put here, and what are the disk spindle speeds, and all this kind of stuff. The big thing is just moving away from that whole idea. Azure Stack is an integrated system. You buy it from OEMs. It's pre-configured. Part of this was driven by the need for Azure consistency. We can't be giving new features in Azure Stack at the exact same speed that Azure gets them if we have to worry about agents on every computer, and if we have to worry about somebody who's put on their own little bits and bobs in the midst of the infrastructure. So we've completely sealed it.
So you mean that if I'm an admin, I cannot go on TechNet and pick whatever registry key I want to set and say, this is better?
You might be able to, because you're a nice guy.
All right. We'll see about that.
So this is the thing. And given that we've been able to make this incredibly strong statement that says, this is sealed, nobody has access to the infrastructure, the fabric, or anything, now we know we have well-defined components, well-defined interactions, and that lets us do very, very agile updates, refactoring, and security.
And so all of a sudden, when Lee and I sat together, was about 2 years ago, I would say okay, what is the security posture? What do we want to bring to our customer in terms of security for Azure Stack? And we quickly realized we had an incredible opportunity that few times in a lifetime it happens. We had no legacy. We could basically pick and choose whatever we wanted to do for the security of our product. That doesn't happen that often. So basically we'd say that we took a very heavy stance on how do we design the security posture of Azure Stack. Starting from it's an integrated system, completely sealed from the outside. So where we have control of everything. And so you don't have a legacy support. We decided to go and adopt these two security principles, harden by default and assume breach. And we will dig into this as we speak.
Those fields behind there, they may or may not be Windows XP. Was not a security inspiration for us. So I want to take a little bit of a digression here. People talk about things like the security basics, right? So security basics, patching is a basic. Network whitelisting is a basic. And there's a lot of shaming out there that goes when it comes to security, like just do the basics. So a basic is something like, how do you tie up your skates in hockey? A basic is something that you learn early in your progression. You get it at some point, and you just keep on going. Patching, network whitelisting, application whitelisting, any of these things, these are not basics. These things are fundamentals. And there's a massive difference here. Fundamentals, Yeah, sure, they're important, but they're a thing. They're a skill that you can build from your very early stages, but they require incredible maturity to do this right.
And by the way, that's Lee during our team meeting. Huh?
Yeah, I decided I was kind of bored. This is Patrick Kane. He's been practicing stick handling in hockey since he was probably 9. Patching is a fundamental. It takes skill, it takes effort.
So let's look into hardening by default. And here we have a gem from the past. This is a video game from what, 80s with lemmings. So it was like a character in this video game. So you could decide basically to place it there and you block everything coming its way. So basically hardening by default, what does it mean with it? Can I get the clicker, please? So we started from the realization that in Azure Stack, we control everything. We control the hardware. We work with our OEM to define what hardware component go there, what firmware level goes there, what driver goes there, what operating system go there. And then once we get out of the hardware, we go to the software. So we decide how the software, what software gets deployed, how it gets deployed, how it gets configured. And that gives a tremendous amount of control to us so that we can really shrink it down and tie the system up that usually is not possible. For example, if you take Windows Server to give you a comparison, Windows Server has to be flexible because when we develop Windows Server, we don't know what kind of hardware is going to be deployed on. We don't know who is going to use it, how they're going to configure it, what kind of application are going to run on top. In Azure Stack, we know all of that. Therefore, we could raise the bar of security and hardening extremely high. So from a hardware point of view, we started from basically taking all the good stuff from the hardware platform can give you. So Secure Boot, UEFI, and TPM 2.0. Those are by default. By the way, there are not that many servers out there in the market that ships with TPM chips 2.0. And Azure Stack, we put as a requirement by default. We also wanted to reduce the attack surface. And again, we control the software. So starting from the baseline, the operating system security baseline. And since when you go into the to customer side, there are a lot of opinions. Here in my company, I use this baseline. Now we want to use that baseline. And since we already had gone through that experience with our previous product, in Azure Stack, we say, you know what? We're going to take the hardest possible baseline available out there, and we're going to put it as default for Azure Stack. And so what we took, we basically took a military-level baseline, the DISA STIG, which is the DoD, the Department of Defense, US Department of Defense baseline, and we applied that by default on Azure Stack. We also remove all the components that are not necessary. We know exactly what we are using, and we know what we don't need. Therefore, we basically remove or disable everything that we didn't need. We also use Windows Server 16 as a base operating system, both for the Hyper-V host and the virtual machine running the infrastructure. And we use all the goodies that comes with it. So we had Credential Guard for credential protection, code integrity, and then we also have Windows Defender across the board. And obviously, then we decided to use only the really safe protocols. And so we only use NTLM, SMBv1, and SSL.
I'm so proud of you for that decision.
So actually, no, we removed all of those because we didn't want to stay up at night dealing with the next attack on ransomware. So that basically, we gave us, since we had so much control, that gave us an incredible opportunity that we took to really bring a lot of value to the customers. And finally, we also said, okay, how we can take a next level. So encryption. Encryption, we heard for the last 2 days how much encryption is important. So we decided, okay, encryption is also very important from a compliance point of view. If you take PCI, which is the payment card industry standards, you take FedRAMP, which is for service provided to the US government, HIPAA, the Healthcare Protection Act, basically it's the standard if you work with medical records. All of those require data rest encryption. And so we say, you know what? Let's enable by default. Why we have to even hassle with it? Just enable by default. So entire infrastructure and entire storage system in Azure Stack is protected by BitLocker.
And this is the kind of thing that, is part of the theme, is that we've been able to make these hard stances. What we've been able to do is say, you know what? We had something that this didn't work on. Let's go and fix it in our infrastructure. and make the hard stance that we're not going to drag along these legacy problems.
Similarly, network encryption. We protect the entire infrastructure, so all the components that you have not seen in the slide that Lee showed you a second ago, all those components communicated with each other through TLS 1.2. So we disable legacy protocol, we disable everything that we didn't need, and everything was unsafe, and we only use TLS 1.2. All the components in the infrastructure, they are strongly authenticated using Kerberos. And so because we have an AD and a PKI inside the infrastructure, that allows us the flexibility to also rotate all the secrets. And as a matter of fact, Azure Stack comes with a automation that allows to rotate all the secrets. And when I say all the secrets, I'm talking about all the certificates, all these storage keys, and also we heavily use the group managed service accounts. With our service accounts, they are self-managed, and we put the password rotation every 24 hours. So if somebody steals a global GMSA password, they have 24 hours to exploit the infrastructure. So it is the smallest value we could possibly set GMSA to rotate. So again, we control everything in the infrastructure. A lot of security, a lot of benefit comes by default to our customers.
So that's like harden all the things, block all the things. One of the things that I will point out is that some things do require incredible pragmatism. I don't know if anybody saw Casey Smith's talk this morning about application whitelisting. He made a great point. You know, like deploying application whitelisting policies to some machines or some degree is going to be better than nothing. And we really took the stance across Azure Stack that if there's a blocker, well, sure, we'll set up something, a silo or something to disable a thing on a little bit, but keep on going with that approach. So we spent a lot of time on security, but we're incredibly, incredibly humble. We know that something's going to happen at some point. And from that perspective, focusing on Assume Breach, of course, is important, right? At some point, your defenses are going to fall. And what do you do from the idea of Assume Breach? Assuming that your defenses are going to fall, put in place the detections and remediation steps to help in that situation.
And so to define our Assume Breach posture or position, we basically started from the assumption that the admin, the administrator, and the privilege that the admins have is our first enemy. And the reason for that is, as we heard yesterday morning at the keynote, 93% of the attacks start from phishing. And guess who is the most attacked role? The admin. Why? Because simply, if you get the keys, if you get the admin credential, you get the keys to the kingdom. And so how do we can basically scope down that attack surface? And the way we did it, basically, we constrained the entire administration experience. In Azure Stack, there are only 3 entry points in the infrastructure to manage an infrastructure. One is the portal. We create an entire new point-and-click, entire admin portal to manage the infrastructure. If the operator doesn't want to use a point-and-click experience, there is ARM with the admin section of ARM. They expose the same functionality. So if you want to use PowerShell, you can use PowerShell to manage infrastructure. But again, if you compromise their account, you'll only be able to run and perform those actions that the system is designed to be. So if you steal the credential and you log into the portal, you're not going to be able to log into the Hyper-V manager or server manager or cluster manager. You're not going to be able to access any VHD underneath. You're only going to be able to click those buttons and perform those actions that the system is designed to be, the action that we validated the system for. And finally, the third level, the third entry point is for a support scenario and very low level operations, and we'll demo in a second. And that's basically where you go, again with PowerShell, but we also scope down and we put a lot of security around that by using PowerShell GIA, just enough administration, and so on and so forth. So we really basically scope down the capabilities and the privileges that an admin needs to have because we put all the automation in the back. So the admin only needs to decide, for example, I want to update the infrastructure. It goes, it can click on a button, and the infrastructure updates itself. There is no need to understand how the infrastructure is together. There is no need to access every virtual machine. There is no need to access the AD. As a matter of fact, the customer or Microsoft or the OEM, nobody has a domain admin credential. the appliance is completely sealed. It's a black box. Nobody can get in. So usually customers start shaking when we tell them you don't have a domain admin credential, but that's the whole purpose, because if you steal a domain admin credential, you kind of are able to do whatever you want. And that's exactly what we wanted to limit. And so that's all the stuff we start putting together to constrain the administration experience.
So we're going to show you a demo right now of what we're calling the privileged endpoint. And this is really moving from the idea that Azure Stack, you're an operator. You're not an administrator, right? When somebody connects up to Azure, they do not have a domain admin cred. They can't go to the virtualization host underneath. But the one thing that Azure does have is it's got a whole slew of DevOps tools. And every virtualization fabric has the way that people are starting to manage these things. So we have needed to give customers a way to do some things in an operator console, integration tasks, extracting logs and stuff.
Can you guys read the fonts here, or should I make it bigger? Yeah? Bigger? All right.
I think it's okay. LASIK for all.
All right. OK, so basically here, I'm on my laptop, and I'm connecting to what we call the privilege endpoint, which is the low-level entry point into the infrastructure. The privilege endpoint is designed to perform action for support scenario, or when you deploy Azure Stack at the customer site. For example, for when the customer have to do ADFS federation, if they want to use AD instead of Azure Active Directory. And so here I'm going to simply log into it. I have my creds, and I open a new session. As you can see, I have the IP number, and I have the configuration name, privilege endpoint. This is a PowerShell GIA endpoint, so just enough administration.
And there's been some presentations about PowerShell just enough administration at previous BlueHats. So this is an example of us just taking some best practice, doing it, and getting a pretty great result out of it.
And so now I connected to this privilege endpoint, and I'm going to do a get command, if I can spell. And there you go. So what you see here, that's a whole list of commandlets available to the admin. As you see, it's just a bunch of getters, like get logs, get user list, start and stop, and that's it. That's the only stuff the admin can do. So if somebody steals this credential, the one I just used to log into it, that's the only action they're going to be able to do, nothing else. They cannot go inside Azure Active Directory. They cannot give themselves domain admin credential, and so on and so forth.
So that's a great example of the privileged endpoint and how it can limit functionality. And so we'll move on. And hold on. What are you doing?
So
Mimikatz, I recognize that word.
So yeah,
that's a bad word. You're a bad guy.
Yeah, I told you not to trust me too much. So what I try to do now is to basically do an invoke web request and download Mimikatz from GitHub. Do that.
Not nice.
So unfortunately, the red on blue is not that great. But basically, it says, hey, that commandlet, invoke web request. I'm not doing it. Is basically not allowed. It doesn't find it. So therefore, it cannot be executed.
Yeah, well, you're stopped.
So I guess the Italian hacker failed at the first try.
Uh-oh, this is getting complicated. We've got an advanced Italian threat here. This is worse than APT. This is...
So let's try to write...
That's the evil detector.
Exactly. So now I'm going to try to write some bytes in memory. Oh, wait. So again, it got blocked. And the reason for this is because when you use a GIA, just enough administration, you actually have a constrained mode. So you only have a subset of the PowerShell features.
So all that stuff you see about in-memory attacks and all that kind of stuff, that's just not going to work here because it's now fallen down to no language mode. And so, I didn't realize this was going to be some pen testing, but go on.
All right. So what I'm going to do now is actually I'm going to go inside infrastructure. So I'm going to, as I said earlier, the privilege endpoint is for support scenarios. So there are scenarios where we expect that the system may be down, so the customer has to go inside with the customer support engineer on the site. And so when they get in, basically they have a full unrestricted access. So I'm going to use that to simulate basically the fact that somebody compromised the infrastructure and is actually acting with domain admin credential inside.
And the important point, so he's going to take you now through the act of unlocking the privileged endpoint. This takes a zero trust model, unlocking this thing. So a customer never wants to have any default creds available to their Azure Stack. Nobody should ever have default access to the infrastructure. We have the same thing. No customer should ever have default access to the infrastructure. So what we started here is a two-key unlock, kind of like that they use in submarines for nuclear missile launches and stuff. So this first stage is where the customer says, I'm ready to unlock the session. This token now goes to customer support. Now customer support can go into a back-end service that we have. This is highly restricted, audited, logged, all that kind of stuff. Now the support can generate a confirmation package that they provide back to customers. And it's this two-key unlock now that will finally unlock a support session where neither Microsoft nor the customer could have done it on their own, but with a great over-the-shoulder kind of chaperoning system, now you can watch a support session in progress.
So just to summarize, we have a two-factor authentication process with two people involved from two different companies, two different systems. So collusion, it's really hard in this case. And so now I'm basically unlocked the infrastructure. As you can see, support session locked successfully. So let's try to run get command again. And now we have the entire PowerShell library. So as you can see now, you have all this, everything. All the setters, you can reach out to AD, you can do pretty much anything you want. But again, you have to keep in mind that this happens only when the customer decides there has an issue, opens a support ticket, the support engineer is on site and helps the customer going through this process. It cannot happen with only one person.
Let's see what you got now, Mr. Advanced Italian Threat.
All right, so first of all, what I'm gonna do, I'm gonna copy Mimikatz from my laptop to the privileged endpoint. This was a fun experiment today when I load Mimikatz on my machine. I got a call from Microsoft Security say, hey, what's going on with your machine? So now basically I copied, and now I'm going to get back into the session. And actually, let me go. And do a dir. And so here you have Mimikatz, okay? So let me clear the logs, and then we are going to try to execute Mimikatz. Boom, blocked. So even though I'm running as
that would have been blocked. That's a zip. Right now it needs to be unzipped. So
no, that's an XE. Oh, I copied the wrong one then. Let's see. Exactly.
Let's just run it on your regular machine. Maybe we can get MSIT to come help.
Please don't.
Why did you?
That was a zip you copied in the... Oh, no, just rename it. You copied it as an XE. No, it should have worked.
I copy as an XE.
Do it again.
All right, hold on.
Let's do some paired programming here.
Okay, here you go. There you go.
Oh, good. This is going to get good now. Let's see some creds.
Okay, so basically now, again, it didn't work. And the reason is because in this case, the defender blocked it right away. Because as soon as I try to execute it, if I do a dir again, it's not there anymore. And as soon as I try to touch it in zip, it will happen the same. So again, I cannot do anything.
Oh, that was it. So as soon as it got on the file system, it got nuked. And that's what made us look silly. Okay, Defender's got our back.
All right.
APT saved again.
Thank you, Defender. So now let's look at the event logs, because obviously now something happened. The system detected something was attacking and also wrote a log. So,
evil detector. There we go.
This is a feature, by the way. So as you can see, here we have an event ID 1117, and it says Mimikatz was tried to be executed. So this will show into your SIEM portal, and therefore you know when you see something like this, you definitely have an issue with your infrastructure, as we have with the projector. And so now let's try to do something different. So we try to download and execute malicious code. So Defender kicked in and helped us out. So let's try now to use or to run code that is actually good. I mean, it doesn't have any problem, like a Chrome. Clean up the logs, so it's easy to read.
Defender is an example of a basic, right? You just do it. You're not amazing at having Defender enabled. It's just enabled. But when you talk about fundamentals of application whitelisting.
So now I'm going to download Chrome, the installer of Chrome. Okay. There you go. So you see here, and now basically I'm trying to execute it. Again, I failed. The reason why I failed is because there is code integrity policy kicking in. The only code that can run in Azure Stack is code that is either signed by Microsoft or by our OEM partners. And since Chrome, even though it's a good piece of software, is not signed by Microsoft, it's blocked. And again, this policy cannot be overruled because it's signed by us, as Dean Wells explained the whole chain of trust with the code integrity. So basically now the system is protected because the only code that can run is the one we decided. And so that's also why customers cannot deploy their agents. Customers cannot deploy third-party software or any other kind of software. You cannot run unsigned scripts. You cannot run PowerShell arbitrarily. And this is happening with me running with a domain admin credential. So even a domain admin is blocked in this case. All right, and then last thing I want to show you, again, the same story, event. And here you have a 377 ID event that says, attempted to load Chrome XE that did not meet the enterprise signing level agreement. So code integrity policy violated.
And this is crazy to think that now you can actually use a code integrity violation as a signal that you've been attacked. Not noise, but by taking the approach where of course we own the build of Azure Stack from beginning to end, we can now take the approach of doing this all as part of the build, as part of the build out, so that anytime there's an integrity violation, you now know that there's a very strong signal that you're actually under attack. That's not just a random thing happening. So we're talking about some things here. One of the big approaches with Assume Breach is constraining the blast radius. Now, one of the big aspects has been around preventing lateral movement. And so we've deployed network whitelisting kind of 3 different ways. So we've got them in the hosts, the host firewall. We have them in the SDN firewalls. And then we also have them in the switch ACLs. And this is, now that we know everything in this system, we can be explicit on what's allowed to communicate. Things getting onto a host don't have outbound access by default unless they're supposed to get it. We've also really gone down the path of least privilege. One of the things that's common in infrastructures is to say that this machine needs full administrative access to this other machine so that it can do arbitrary WMI or arbitrary PowerShell. We've taken a very strong stance there that says, we're not going to do that. Instead, we're going to say that all interactions within the infrastructure, it goes over something like a REST API, where the listener of the REST API can then take actions on behalf of the approved methods. Or we've also done this pretty heavily with GIA endpoints. So one part of the infrastructure can reach out using just enough administration and only have the explicit 5 or 6 things that they're supposed to do. Now you turn that crank over and over and over, and you don't have to worry necessarily about a machine getting popped and then those administrative credentials being used anywhere, because there is no broad administrative privilege.
So just to be clear, so the GIA and the whitelisting of the interfaces does not only happen in the privilege endpoint. Every component in the infrastructure talks with other component only through whitelisted interfaces. They can either be GIA, if they use PowerShell remoting, or REST APIs. So that's why lateral movement are going to be much more complex, because the set of APIs, the set of function or commandlets that you can call on another component, it's very small, and it's only those commandlets, those functions that the system is designed to execute. And with Assume Breach, yes, we focus a lot on preventing the breach, but also we focus a lot on detecting the breach. In average, in the industry, the detection time from when a breach happens to when they realize that the company, the enterprise is breached, is 200 days. That's the average worldwide. So a lot of what Assume Breach is focusing on how we detect the breach. And so in Azure Stack, you saw here during the demo how obviously all these events, all these actions like Defender kicking in or code integrity policy kicking in, you have all these events created. And we are basically collecting all those logs from all the component infrastructure, and we move them, we centrally store them in a storage account. And from there, there is a REST interface the customer can use or third-party software can use to pull those event logs, those audit logs, security logs out and attach them to a SIEM system. And we are working with partners, to ISV partners, to basically have this integration very smooth for customers. Because again, when you standardize on an interface, when you have a very clear procedure, then you can also work with the ecosystem to help us and help a customer to have a better experience. And here you actually have an example. This is an event tracker, one of the partners we integrated with. And they have here, actually, I cannot really, I don't know if you can see here. So this is the event integrity policy code violation, and also the Defender event ID that happened before. So Azure Stack is not just Microsoft. Azure Stack is a partnership between Microsoft and the OEM. And the one thing you don't want to happen is that, hey, look at how all the great work we have done, but then you have the other side of the house that if they don't do the same work, then the customer will see the seam between, right? So we push the same requirements, the same security posture across the board. Also because the OEM include a server, a physical server, and some software to manage the hardware and to monitor the hardware. So basically the same security posture, the same baseline, the DSSTIC, the same principle of constraint interfaces, and so on and so forth, data rest encryption, data in motion encryption, we actually enforce it also on the customer, on the OEMs. And that all created a holistic security posture across the board between the Microsoft components and the OEM components so that the customer can only see one piece.
The genesis of all that is like, everyone is sick of getting, some great solution finally messed up by somebody who's got a trivial buffer overflow or some static default password. In fact, we had some OEMs, all of the OEMs, going through pen testing, and we had one customer, one OEM, that as part of this, they were shocked. They were really shocked. They are in the midst of essentially the Microsoft equivalent of a SERP, because as part of their pen testing, they found some code that they had inherited through some purchases 10 years ago, and they found something that they're really not happy that they've been accidentally shipping for the last 10 years, and so they're in the process of remediating it. And so this has not only helped Azure Stack, it's not only helped those customers, but it's also helped the open source libraries that they're depending on. So it's really borne some good fruit.
And that was a really fun story because the same OEM at the beginning was very reluctant to invest and spend hundreds of thousands of dollars in doing pen testing. So when they found us out, they actually were very happy and they thanked us for pushing those requirements to them. And also in terms of patching, we said patching is one of the fundamentals. In Azure Stack, we built and invest a lot of effort and resources in creating an orchestration engine that basically takes care of updating the entire infrastructure. Because Azure, the public cloud, moves very fast. And if we don't bring our customer fast with us forward, then the delta between Azure and Azure Stack will diverge too much to the point that we'll break the entire promise of Azure Stack, which is the consistency with the public cloud. And so basically what we had to do is to have this orchestration engine that takes care of updating the entire infrastructure, and so that the customer can consume updates on a monthly basis. And we even enforce on customers a 3 months patching window. That means that a customer will fall out of support after 3 months that they don't patch their infrastructure. So because we don't want to have any more customers that are running Windows 2003 or Windows XP. They need to be 3 months. They can be at most 3 months behind. After that, you're on your own. And that basically is a very strong forcing function when you work with enterprises, so that they have to come along. And one of the good benefits with Azure Stack is that, as I mentioned already over and over, is that since we control everything and we decide how everything is configured, we decide how the infrastructure is used and managed, that also brings a lot of benefits when it comes to compliance, which, by the way, customer told us being the #1 headache to put a system in production. And what we did in Azure Stack, basically we built a lot of the compliance requirements directly in the infrastructure. So the Azure Stack can basically meet the requirements from the major compliance standards out there from the get-go without customer investing a lot of time. And we didn't stop there. We basically also hire a third-party assessor company to do a formal assessment on how Azure Stack meets those requirements and those standards. And we are starting with PCI, again, credit card information, and the Cloud Control Metrics Cloud Security Alliance, which is a meta mapping of 1 to 30, if I'm not mistaken, different standards worldwide. So basically, Azure Stack is ready to go from a compliance point of view. It's not certified because we cannot certify Azure Stack because all of these standards basically have controls or requirements that fall into 3 buckets. You have this technology piece, you have the people, and the process controls. So since we do not own and operate Azure Stack, we cannot define and answer how customers are meeting the people and process controls. We can only respond for the technology part. But we are giving them all the documentation so they can jumpstart the process. And so now we built the infrastructure from scratch, and we basically had an incredible evolution. So going from a general purpose building blocks, where you have networks, hardware, software, the operating system, middleware, framework, and applications. And then you have to define your processes. Again, talking even about compliance with security, how you secure the infrastructure, and then everybody's going to have an opinion on that, how you update the infrastructure, where everybody has to decide, am I going to update it, or it just works, I'll keep it that way. Just to give you an example, I was with a very, very large customer last week, and when I told him about the 3 months patching window, I said, well, we update once a year. And he asked me, oh, so how does it work with Azure Stack? I said, well, in Azure Stack, you cannot do it, 3 months. And so you remove all these kind of issues, and as well as management. So you remove, when you have these situations, you have a lot of opinions, a lot of duplication, inefficiencies, and at the end of the day, security risk, like the customer that was patching their infrastructure once a year. So moving to today, you have a certified solution, where it's based on a hyperscale cloud infrastructure that runs IaaS and PaaS services that are used by millions of people around the world, battle tested by our public cloud, brought down to the on-prem, and then you have well-defined process for security, well-defined process to update, well-defined process to management. And so at this point, you have a hardened infrastructure, well-defined hardware and software combination, well-defined interaction, well-defined administration, which brings a much, much better security to our customers.
And the point of this presentation today is to not get you all to run out and buy Azure Stack. Like, you can if you want to, it'll be fun, we can chat about that. But the point is to realize that by taking a hard stance on security and really winnowing down the list of variables and just really, really driving down that, you can really, really make some magic happen.
And this is only the beginning, because again, we seal the infrastructure, we seal the entire management experience. So that allows also to expand. This is what we told you today, just the beginning. So now we can iterate and increase even more the security posture. And with that, I hope this was interesting to you, and we'll be happy to take any question if you have.
Thank you.
Thank you.
So during the Q&A section, please make sure that if you do have a question, wait for a mic runner to get to you so that everybody can hear it. Questions about Azure Stack and what it does and doesn't do? There we go. I knew we had to have at least one.
So I noticed in a few of the commands there were some commands for ADFS. I'm just curious, is that actually built into Azure Stack? And if you could talk a little bit about the identity conversation with respect to identity.
So Azure Stack has two ways for customers to use identity within Azure Stack. One is Azure Active Directory, cloud connected, and the other one is synchronizing it to their directory through ADFS. And that is what gives them their tenant identities.
So with those commandlets you saw is basically when we deploy Azure Stack in day one, is to do the ADFS federation, so to establish that trust.
Additional questions? I know it's late in the day, but there's always a couple left.
How much scalable is Azure Stack in terms of, like, I saw some of the demos at the Ignite with 25 terabytes RAM and, thousands of cores and whatnot. So if I have a Azure Stack at my location, like how scalable I can be, like, what is the limitation I'm looking at?
So as of today, Azure Stack, basically, let me make a step back. When you talk about scaling Azure Stack, you have the console cloud, like you have on Azure. You go on azure.com, you have the portal. When you basically go to the portal, you can select which region you want to go to. And then within each region, there are what we call the scale units, right? So there are fault domain, if you want, or different units. So Azure Stack, as of today, has one cloud, one region, one scale unit. So this is, as of today, at GA. Very soon, we're going to expand, offering multi-region and also scale unit within a region. So that's just a matter of months. In the next few months, you will have this scale up. And in terms of physical nodes, right now we go from 4 nodes from physical server per scale unit to 12. And also from that 12 is going to be increased soon, but again, it's just a matter of because we just GA'd this summer, so we are just getting there.
Last call for questions. Thank you, everybody, for your time. Big thanks to Filippo and Lee for giving us a tour of Azure Stack.